Hi there, welcome back to Spring Into Math 7. I'm Mrs. Campbell, and today we're going to be talking about integers and rational numbers. Let's get started. Okay, so before we really dig into rational numbers, I just wanted to show you a graphic that might help you visualize exactly what real numbers, rational numbers, irrational numbers, sometimes the vocabulary in pre-algebra can get a little bit confusing. So it's a good idea to really take your time and understand the terminology behind the math. So let's start here with irrational numbers. Now, irrational numbers are pretty unique. Irrational numbers are numbers that are non-repeating decimals. Now, what do I mean by non-repeating? First, I'll show you what a repeating decimal is. A repeating decimal would look something like this. 1, 2, 1, 2, 1, 2. It's repeating. The numbers go over and over in the same pattern. An irrational number would not be repeating. So an irrational number, when I say non-repeating, I basically mean something along the lines of 0.357, 1, 0, 2, on and on and on and on with no repeating numbers or digits. Okay, so that's basically what I mean when I say non-repeating. That's the first thing that has to happen, or one of the ways that a number can be an irrational number. The other thing, the other type of decimal it would need to be is non-terminating. Now what I mean by that is it doesn't end. You may have a decimal, something like 0.357, and it stops there. It terminates there. An irrational number would go on and on and on and on and on indefinitely. It wouldn't end and it wouldn't repeat. So that's basically all we're talking about when we say that something is an irrational number. It's a decimal that is non-repeating and non-terminating. Okay, but today really I want to focus on rational numbers. Now rational numbers are integers that can be written as a over b, where b does not equal 0. Let's take a little bit deeper look at this. Okay, fractions are a really good example, a good place to start when we're talking about rational numbers. It's also important that you can identify the different types of fractions. Let's start with proper fractions. Now, proper fractions are probably the easiest ones to work with. They are rational numbers where the numerator, or the number on top, is smaller than the denominator. Perfect example would be 1/2. So the numerator is smaller than the denominator. That is a proper fraction. An improper fraction is where the numerator, or the number on top, is larger than the number on the bottom, or in the denominator. So let's use 8/5 as an example. That is a perfect example of an improper fraction. Okay, also, it doesn't technically have the word fraction in it, but it does include a fraction. We have the terminology of a mixed number. Now, a mixed number is an integer, or a whole number, plus a proper fraction. So in our example of 8/5, we had that improper fraction. Probably you've done a lot of these before, where you're trying to turn an improper fraction into a mixed number. 8/5 can be simplified into the mixed number of 1 3/5. It's pretty simple, and I'm guessing you've probably had quite a bit of practice with that one, with turning improper fractions into mixed numbers. And then also I just wanted to take a second and talk about equivalent fractions. It's really important that you have a strong working knowledge of equivalent fractions, especially when we're ordering integers. So equivalent fractions are two fractions that give the same numerical value when evaluated. So for example, 4/8 is the same as 2/4 is the same as 1/2. And in our next lesson, in our next video, we'll be looking at some graphics that explain that even a little bit more clearly. Okay, so when we're ordering rational numbers, it can get a little confusing, especially if you have denominators that are not the same. But it's actually a simple problem to solve. All you have to do is find a common denominator. So let's take a look at how we would do this particular problem. The question asks, which is greater, 3/7 or 4/9? So all you have to do basically is find a common denominator and then look at the numerator and determine which one is greater or less. So the first step, find your common denominator. So the common denominator for these fractions is going to be 63. So 3 over 7, we would have to multiply that by 9 because our denominator is going to be 63 for both fractions. Then we also have to, we always want to do the same thing to the numerator that we do to the denominator. Sorry, I wrote on the 9 there. 3 times 9 is 27. And if we have to multiply 9 by 7 to get to 63, we also have to multiply 4 by 7, which gives us what? 28. So now this problem is just as simple as can be. We've got 27 over 63. Is that greater than or less than 28 over 63? As long as you get a common denominator, then you're just looking at the numerator and which is greater. So obviously 27 over 63 is less than 28 over 63. Then we want to simplify those fractions again back to the original state, which is 3 over 7 is less than 4 over 9. All right, guys, that pretty much does it for today. We'll see you next time. Thanks for joining us.